Hey, sorry. Um, I am out today, as you see from having a sub and watching this video. Today I just want y'all to finish the work from yesterday. I know that not all classes and not all people in all classes totally finished numbers 1 through 10 on page 31 through 33. Um, so that's what I want you to focus on today. I made this video for the last part, the 8, 9, and 10 numbers that don't really have the story to go along with it, and it's just like a quote unquote pure math problem, right? They ask you to solve the following quadratic inequalities. I've done an example here. Hopefully, it's not the same one as one in your book. I did just make it up. But first, I want to talk about what does it even mean to solve these. Whenever we say solve an equation, we mean find all x's that you could plug into this equation that would make it true. That you can plug in. Let me actually just type this. Yeah, the solution means find all x values that you can plug into the equation. It makes the equation true. Right? Usually, when we're doing quadratics, we can find two numbers that make this true because it's an equal sign, and quadratics have like two solutions to most things, right? Here, however, we're going to get a lot of numbers, infinitely many numbers, right? Because there are a lot of things that make this true. For instance, if you plug in 0, if I plug in x equals 0, I get 0 squared minus 5 times 0 plus 24. That simplifies to 24, which is definitely bigger than 0, right? There's a bunch of numbers that work for this that make a positive answer. There's 2 that make it exactly 0, and then to be honest, there's a bunch of them that make it negative as well. So what we're going to do whenever we're answering quadratic inequality questions is we're going to basically break down the entire space. Whoa, didn't want that. We're going to break down the entire space. We're going to say everything that makes it positive, negative, and 0, and then we are going to kind of highlight which ones we actually care about. Here, the positive ones. All right, so first you're going to find where it actually equals 0. Find where the function actually equals 0. So to do that, I copy down my function, I set it equal to 0, and then I can do a bunch of stuff. I can factor, I can use the quadratic equation, I can set it equal to vertex form, and then solve for x. Here, I am going to choose to factor. Oh, except I've messed it up. Let me change this so it actually works. Let's make this one negative. All right, so if we're looking at x squared minus 5x minus 24, I can say that I can factor by doing x minus 8, x plus 3. Because negative 8 times positive 3 is negative 24, and negative 8 plus 3 is negative 5. Great. And that means my actual points where it equals 0 are positive 8 and negative 3. If I plugged in positive 8 to x squared minus 5x minus 24, it would give me 0. Same thing if I plugged in negative 3. Cool. Yes, nice. I just was checking that to make sure it was true. Great. Now, second, I want to find or I want to section up the number line where these are like my endpoints of my sections. So here's the entire number line, and I want to say I want to look at things that are smaller than negative 3. That's an interval I'm interested in. I want to look at sections or numbers that are bigger than positive 8. That's a section I'm interested in. And I also want to look at the section between negative 3 and 8. That's a section I'm interested in. The truth is, if I plug in any number above 8, 9, 10, 11, 12, a million, 2 million, 80 million, right? I'm only ever going to get either positive numbers, like all of those values will give me positive numbers, or when I plug in numbers bigger than 8, every single one of them will give me a negative number as my answer in my original equation, right? So everything in this interval, every number that is bigger than 8, if I plug it into this equation, will either give me a positive or give me a negative. Same thing over here. Every number before -3 will either be positive or negative when I plug it into the equation. And every number between 3 and 8, so this, or -3 and 8, right, will either give me a positive or negative number. So now I want to figure out, okay, is it positive or is it negative? Let's do it. So I sectioned up my number line. I found my 3 intervals that I care about. And then my third step is I pick a point from each section, from each interval, and plug it into the original equation. Right? So let's do that here. My original equation is x squared minus 5x minus 24. I'm going to write it down here. Let's pick x equals 0 from this section. Let's pick x equals 10 from this section. And let's pick x equals -10 from this section. These are just my favorite numbers in each of these intervals. It doesn't actually matter. All right, if I plug in 0, I get 0 squared minus 5 times 0 minus 24. And now that I change this to a minus, everything in this blue middle section will give me a negative number. So I'll write a negative up here. If I plug in a 10, I get 10 squared minus 5 times 10 minus 24. That is 100 minus 50 minus 24, which is 26. That is a positive number. And over here, if I plug in negative 10 squared minus 5 times negative 10 minus 24, I get positive 100 plus 50 minus 24, which is 126, which is, again, a positive number. All right, so our third step was to see which sections are positive or negative. And we've done that. And now I get to answer the question, right? Now I get to find all values that I can plug into the equation that makes it true. The thing that makes this true is that we're bigger than 0, right? If we want bigger than 0, that means we're looking for positive numbers. So here, our positive numbers are this section that's lower than -3 and this section that's higher than 8. So my final answer here in this box would be all of the numbers less than 3, as well as all of the numbers bigger than 8. Final answer. Y'all, that's what we're doing today. I'm going to post these notes in this video on the Google Classroom, and you can help your groups, help each other, go team. I'll see you tomorrow, most likely.